let's examine what's called the resonance energy or the resonance effect present in benzene and really all aromatic compounds. Okay, so we're going to illustrate this by calculating the enthalpy of reaction for the conversion of cyclohexa-1,3,5-triene into benzene. All right, the reason I'm labeling it like this and drawing it this way is that the idea of cyclohexa-1,3,5-triene implies that there are 3 double and 3 single bonds between the carbons in the hexagonal ring. Right? If you draw it as shown on the right, where we sort of put the circle in the middle, it implies that really all the bonds are equal and that multiple bond is shared over, or those 3 multiple bonds are shared over all 6 sites, which is the real correct interpretation of benzene. Okay, you'll notice also on the cutout here of the bond enthalpies tables from the data booklet that there's different values for the length, both the length and strength of carbon-carbon bonds in benzene. All right, so there's a specific value for benzene there. All right, so let's have a look here. If we're going to treat this as a bond enthalpies question, bonds broken minus bonds formed is equal to the enthalpy of reaction. So we're going to break the bonds in cyclohexa-1,3,5-trienes. We're going to break 6 carbon-hydrogen bonds. We're going to break 3 CC double bonds, and we're going to break 3 CC single bonds. From that, we're going to subtract 6 carbon-hydrogen bonds and 6 carbon-carbon benzene 1.5-ish type bonds. All right, illustrated this way. Okay, I would get the values, or the appropriate values, from the multiple bonds data down here. So that's the benzene value. Just be aware that it's there if you ever have to carry out this type of calculation or bond enthalpies question whatsoever on a test or an exam. Benzene has a different value and it's specific to the aromatic system there. Right? I know that the 6 carbon-hydrogen bonds are present in both sides of, or in both terms here, so I actually don't need to account for them. So really, I'm just going to put a line through them, eliminate them from this question. All right, and I'm going to focus on the 3 carbon-carbon double bonds and 3 carbon-carbon single bonds as compared to the 6 carbon-carbon benzene bonds. All right, so we'll take care of the cyclohexatriene term. We'll subtract the benzene term. All right, and we'll pull up a calculator here. And we can see that the enthalpy of this reaction is negative 162 kilojoules per mole. This implies that the benzene form of this molecule is the more stable one. So if we were to draw this as like an enthalpy level diagram, we would show cyclohexa-1,3,5-triene as a product, and then we would show at a slightly lower level benzene, cyclohexa-1,3,5-triene as a reactant and benzene as a product at slightly lower level on your y-axis, which would be your enthalpy axis. All right.